Well, last time we discussed about first order reaction. Okay, first order reaction. First order reactionৰ কথা আমি ডিসকাস কৰিছোঁ ন এইটো যদি এটা ফাৰ্ষ্ট অৰ্ডাৰ ৰিয়েকশ্যন হয় এইটো যদি এটা ফাৰ্ষ্ট অৰ্ডাৰ ৰিয়েকশ্যন হয় ইনিশিয়েলি টাইম ইকুৱেল টু 0 initially. So concentration of reactant is maximum. Concentration of product is 0. At time t, concentration of reactant is RT and concentration of product is PT. Okay? এইটো এটা ফাৰ্ষ্ট অৰ্ডাৰ ৰিয়েকশ্যন প্ৰথম ক্ৰমৰ বিক্ৰিয়া টাইম ইকুৱেল টু 0 আৰম্ভণিতে ইয়াৰ কনচেন্ট্ৰেশ্যন মেক্সিমাম R নট আৰু টি সময়ত ইয়াৰ কনচেন্ট্ৰেশ্যন RT তাৰমানে ইমানখিনি বাকী আছে দেই ইমানখিনি বাকী আছে আৰু ইয়াৰ ইমানখিনি ফৰ্ম হৈছে টি সময়ত আৰু আমি চাইছিলোঁ যে ফাৰ্ষ্ট অৰ্ডাৰ ৰিয়েকশ্যনৰ ৰেট কনষ্টেণ্ট equal to this and that was equation 5 okay আৰু RT concentration of reactant at time t সময়ত reactantor concentration কিমান বাকি আছে that is equal to this আৰু t সময়ত productor concentration কিমান concentration of product at time t equal to this. We have seen this. Now, here from equation 3, okay, let us see one thing. Say, let me make a table. Say time equal to 0. When time equal to 0, e to the power 0 equal to 1, okay? Then concentration of reactant, time equal to 0, concentration of reactant will be R naught, okay? E to the power 0, R naught. When time is infinity, that is e to the power minus kt, that is equal to 1 by e to the power kt, okay, kt. So time infinity, 1 by infinity equal to 0, 1 by infinity equal to 0, so this becomes 0, okay. Say time say 1 second, then RT will be equal to, okay, time 1 second, so e to the power minus kt will be equal to e to the power minus k, that will be equal to 1 by e to the power k, okay, 1 by e to the power k, that means it will be equal to R naught by e to the power k, okay. Time say 2 second, so it will be R naught by e to the power 2k and so on, okay. তাৰমানে কি হ'ল as time increases concentration of reactant you see decreases, okay. Time 0, concentration of reactant is R naught. Time 1 second, concentration of reactant is this divided by this decreases, okay. 2 second, RT equal to this divided by e to the power 2k, still decreases, okay. That as time increases, concentration of reactant decreases, okay. Let me show it graphically. This is RT and time. Okay, so you see, when time is 0, when time is 0, this is r naught. Suppose this is r naught. Okay, this is r naught. As time increases, 1 second, 2 second, 1 second, 2 second, 3 second, time increases, concentration of reactant decreases. Okay, concentration of reactant decreases. 3 second decreases. Okay, concentration of reactant decreases, and concentration of reactant will become 0 when time is infinity. Tamne, what does it mean? When time is infinity, only then concentration of reactant will be 0. Time infinity holehe reactantor concentration 0. তার মানে কি? তাহলে reactantor concentration 0 নহবই. Okay, so the graph will be like this. Okay, graph will be like this. Graph will be like this. This graph will not touch this. এই গ্ৰাফডাল ইয়াত লগ নালাগিব. কিয় লগ নালাগিব? ইয়াত লগ লাগিলেতো কনচেন্ট্ৰেশ্যন উইল বিকাম 0. Okay, so graph is like this. তাৰমানে কি হ'ল যে if we can say that if first order reaction is never 100% complete. First order reaction 100% complete নহয়. 100% complete हुआ माने कि 100% complete हुआ माने कि there is no reactant. Reactant is 0. There is no reactant. 100% complete हुई. That means all the reactant has been converted to product. There is no reactant. Okay, গতিকে ৰিয়েকশ্যনটো 100% কমপ্লিট হোৱা মানে কি গোটেইখিনি ৰিয়েক্টেণ্ট প্ৰডাক্টলৈ কনভাৰ্ট হৈছে. তাৰমানে ৰিয়েক্টেণ্টৰ আৰু বাকী থকা নাই, তাৰমানে 0. আৰু সেইটো কেতিয়া হ'ব? টাইম ইনফিনিটি হ'লেহে. চ' টাইম ইনফিনিটি হ'লেহে 0 হ'ব. চ' উই সে ডেট এই ফাৰ্ষ্ট অৰ্ডাৰ ৰিয়েকশ্যন ইজ নেভাৰ 100% কমপ্লিট. অ'কে, similarly, if we draw a graph for the product, so here you see say time now pt. Okay, when time is 0, e to the power 0, 1 minus 1 0, this becomes 0. Okay, when time is infinity, okay, 1 by infinity 0 0, so this will be equal to r naught. Okay, so this and so on. That means ebar ki hobo, we can show this. তাহলে as time increases concentration of product increases. As time increases, concentration of product increases. Okay, but concentration of product will never become equal to concentration of reactant. Okay, productor concentration কেতিয়াও reactantor initial concentrationৰ সমান নহ'ব. Okay, product of the concentration of the product will never be equal to the initial concentration of the product. So this is the initial concentration of the reactant, initial concentration of the reactant. So as time increases, concentration of product increases. So now the graph will be like this. graph will be like this. So this graph will not touch this. Okay, it will be like this. This is for product, concentration of product. Okay, so concentration of reactant decreases as time increases, but concentration of reactant does not become zero. Similarly, concentration of product increases as time increases, but concentration of product will never become equal to the initial concentration of the reactant. Okay, so this. Next, let us talk about half-life period. Okay, half-life period. Half-life period. T half. So once again, this is the reactant, this is the reaction. Initially, time equal to 0, concentration is this, concentration is 0. At time t, concentration is RT, concentration is PT, or at T half. Okay, what is half-life period? When half of the initial concentration, when half of the initial concentration of the reactant is converted to product. ৰিয়েক্টেণ্টৰ আৰম্ভণিতে যিমান কনচেন্ট্ৰেশ্যন আছিল তাৰ আধা প্ৰডাক্টলৈ কনভাৰ্ট হয়। যিমান সময়ত ৰিয়েক্টেণ্টৰ ইনিচিয়েলি যিমান কনচেন্ট্ৰেশ্যন আছিল তাৰ আধা প্ৰডাক্টলৈ কনভাৰ্ট হয়, সেইটো হৈছে হাফ লাইফ পিৰিয়ড। গতিকে হাফ লাইফ পিৰিয়ড হ'লে এট হাফ লাইফ পিৰিয়ড লেট মি ৰাইট ইট লাইক দিছ, টি হাফ কিমান হ'ব? ইনিচিয়েলি ইট ৱাজ দিছ and half of this converted, that means this is converted, so how much remains? R naught by 2. Okay, so আধা প্ৰডাক্টলৈ কনভাৰ্ট হৈছে, গতিকে কিমান বাকী থাকিল? আধা বাকী থাকিল। Okay, now if we use equation 5, let me use equation 5. Okay, let me use equation 5. 5 I can write like this, T equal to 2.303 by K log R naught by RT. Okay, so when T is T half, then it will be 2.303 by K log of, this is R naught, and A2 kiman hobo? This will be equal to R naught by 2. So this cancels. Okay, so this will be equal to 2.303 by K and log 2. Now value of log 2 is 0.301. 2.303 by K into 0.301 log 2, 0.301, and if you simplify this, 0.693 by K. Okay, so half-life period of first order reaction. Half-life period of first order reaction is constant. This is constant, so half-life period of first order reaction is constant. Okay, or we can say that half-life period of, or we can say that half-life period of first order reaction is independent of the initial concentration of the reactant. Okay, initial half-life period of first order reaction is independent of the initial concentration of the reactant. First order reactioner half-life period বিক্রিয়কৰ প্ৰাৰম্ভিক গাঢ়তাৰ ওপৰত নিৰ্ভৰ নকৰে। ওকে, এতিয়া আমি জিৰ' অৰ্ডাৰ ৰিয়েকশ্যনৰ ক্ষেত্ৰত কি পাইছিলোঁ? জিৰ' অৰ্ডাৰ ৰিয়েকশ্যনৰ ক্ষেত্ৰত পাইছিলোঁ যে হাফ লাইফ পিৰিয়ড অফ জিৰ' অৰ্ডাৰ ৰিয়েকশ্যন ইজ proportional to the initial concentration of the reactant. Okay, আমি আগতে পাইছিলোঁ, we have already discussed half life period of zero order reaction is proportional to the initial concentration of the reactant. Okay, so you see we discussed half-life period of zero order reaction is proportional to the initial concentration of the reactant. কিন্তু ইয়াতে আমি কি পালোঁ? half-life period of first order reaction is independent of the initial concentration of the reactant. Okay, so now small questions may be asked. Okay, suppose এটা question দিছে rate constant of first order reaction is 5.2 into 10 to the power minus 3 per second. Okay, calculate the time required for the concentration of the reactant to fall to 1/2 and 1/4. Okay, 1/4 of the initial concentration. Okay, so there are two problems. One is 1/2 and the other is 1/4 of the initial concentration. Okay, so very simple. Now, so 1/2 means half-life period. 1/2 is half-life period. Okay, so what we have to calculate here, we have been given rate constant equal to 5.2 into 10 to the power minus 3 per second. Rate constant is given. Okay, rate constant দিয়া আছে আৰু আমাক কি কৈছে? Calculate the time required for the concentration of the reactant to fall to 1/2 of the initial concentration. That means it is half-life period. We have to find out half-life period. That is number one problem. we have to calculate half-life period. So this is equal to 0.693 by K. So you just put the values 5.2 into 10 to the power minus 3. This is second inverse. So upor ahile it will be second. So you just simplify, you will get this. Let me write it like this. This is second inverse. Now it will be second. It will be second. Okay. Similarly, you can solve like this also. You can solve like this also. There are different methods. I can solve this problem by using different methods. Okay. So here, this is the reaction. Okay. This is the reaction. So initially we have R naught. Initially we have R naught, and we have to find out the time. We have to find out the time when this will become, when RT will become equal to 1/4 of R naught. We have to find out this. Okay, so we can use this T equal to 2.303 by K. Okay, what is K? 5.2 into 10 to the power minus 3 second. 2.303 by K. K equal to this log of R naught, and this is 1/4 R naught. Okay, then R naught cancel, so this will be equal to minus okay 2.303 5.2 into 10 to the power minus 3 second into log 4 equal to 2 log 2. So this will be equal to 2.303 5.2 into 10 to the power minus 3 into 2 into 0.301 second. You just simplify and you will get the answer. Okay, you can solve like this. You can solve in different ways also. There are other ways. Say another problem you see. Show that the time required for 99.9% completion 99.9% completion of a first order reaction is nearly 10 times of the time required for 50% completion. Okay, 50% completion. Time required for 99.9% completion is nearly 10 times of the time required for 50% completion. We have to prove this. So we can solve like there are different methods. Let me show one method. So this, say initially we have R naught. Okay, at T, let me write it like this, at T 50% completion. 50% completion. So R50, okay, R50 will be equal to R naught. Half will be converted. So if I assume this to be 100, so this will be equal to 100. Half is converted, so it will remain 50. And at T 99.9, so what we get? R 99.9. This will be equal to 100 minus 99.9, that is equal to 0.1. Okay. Now, if we use the expression, if we use this, say T50 equal to 2.303 by K log R naught equal to 100, then 50 RT equal to 50, and this equal to 2.303 by K log 2, and that is equal to 2.303 by K into 0.301. Similarly, T 99.9, that is equal to 2.303 by K log 100 by 0.1, and that is equal to 2.303 by K, that will be equal to log of 100 means 10 square, 0.1 means 1 by 10, okay. So it will be 1000, log 1000 means 10 to the power 3. So this will be equal to 2.303 by K into 3 log 10 equal to 3. Now if you do this, say if you take this ratio, say T 99.9 T50, so if you take this ratio, well, this will cancel, okay. So this divided by this divided by this divided by this, so this will cancel, okay. Then this will be equal to 3 by 0.301, so that is approximately 3 by 0.3, so this is equal to 10, okay. So T 99.9 is nearly, so here T 99.9 is nearly 10 times T50. So we can do this. There are other methods also. You can solve it by using other methods. So you just try to find out what the other methods may be. তুমি বেলেগ ধৰণেও প্ৰব্লেমটো সলভ কৰিব পাৰা, আৰু তুমি এইটো নিজে কৰি চাবা আৰু okay. This is first order. This is all about first order reaction, okay. Now let me talk about pseudo first order reaction. Pseudo first order reaction. Now let me take an example. Suppose this is the reaction: CH3Br plus OH minus, so alkyl halide. This is aqueous potassium hydroxide dissolved in water, okay. This is aqueous potassium hydroxide. potassium hydroxide dissolved in water. So what we get? From alkyl halide we get alcohol. We get alcohol. We get alcohol. Now when the concentrations of CH3Br and OH minus. Once again, what is OH minus? OH minus, what is OH minus? This is aqueous potassium hydroxide. Potassium hydroxide dissolved in water. Now when the concentrations of alkyl halide, bromomethane and aqueous potassium hydroxide are comparable. Comparable means almost equal. When the concentrations of this and this are almost equal, then R becomes equal to K into CH3Br and this. R becomes equal to this. So order with respect to bromomethane 1, order with respect to aqueous potassium hydroxide 1, bromomethane সাপেক্ষে order 1, aqueous potassium hydroxide সাপেক্ষে order 1. So what is the overall order? Overall order is 2. 1 plus 1, 2. Overall order is 2. It is second order reaction. So when concentrations are almost same, the reaction is second order. Okay, but when suppose concentration of OH minus aqueous potassium is greater, okay, greater than concentration of CH3Br, okay, say more than 10 times, ইয়াৰ কনচেন্ট্ৰেশ্যন 10 গুণতকৈ বেছি আৰু বুজিছেনে? So when concentration of this is greater than this, more than 10 times, 10 গুণতকৈ বেছি, okay, then it is found that R becomes equal to K dash this. Okay, that means reaction is first order. তাৰমানে যেতিয়া ইয়াৰ কনচেন্ট্ৰেশ্যনটো বহুত বেছি হ'ব, তেতিয়া ইয়াৰ কনচেন্ট্ৰেশ্যনটো আমি চেঞ্জ নোহোৱা বুলি ধৰিব পাৰোঁ. When concentration of this is very high compared to this, then we can assume that as if concentration of aqueous potassium hydroxide does not change. We can assume this. So concentration does not change means it is constant. So we can write like this. Okay. Now the reaction becomes first order. When concentration are almost same, second order reaction. When concentration of one of the reactants is much higher, then the reaction becomes a first order reaction. So this type of reaction, now this is called a pseudo first order reaction. Okay, তাৰমানে এটা ৰিয়েক্টেণ্ট বহুত বেছি থাকিলে আনটোতকৈ, তেতিয়া ৰিয়েকশ্যনৰ স্পীডটো কাৰ ওপৰত ডিপেণ্ড কৰিব? যাৰ কনচেন্ট্ৰেশ্যন কম হয়. Okay, in that case a reaction may become a pseudo first order reaction. So this is one example. Similarly, if you consider another reaction, suppose this is okay. Okay, CH3, CH3. This is ester, CH3. Okay. So methyl acetate, methyl acetate. This is methyl acetate, ester, in presence of acid, in presence of acid. So what we get? We get acid and alcohol. We get acid and alcohol. Hydrolysis, reaction with water. Reaction with water is hydrolysis. So this is hydrolysis of ester, ester, methyl acetate. Hydrolysis of ester in presence of acid. Now, this reaction is found to be, rate of this reaction is equal to constant into CH3 COOCH3. Okay, though there are two reactants, ester and water. দুটা ৰিয়েক্টেণ্ট আছে, কিন্তু ৰিয়েকশ্যনৰ স্পীড কাৰ ওপৰত ডিপেণ্ড কৰিব? ইয়াৰ ওপৰত ডিপেণ্ড কৰিব. হোৱাই? বিকজ জেনেৰেলি ৱাটাৰ ইজ ইন লাৰ্জ এক্সেছ. পানী বহুত বেছি পৰিমাণে থাকে জেনেৰেলি. চিন্স ৱাটাৰ ইজ ইন লাৰ্জ এক্সেছ, চ' rate of the reaction is this, though there are two reactants. So again, order of this reaction is 1. So again, this is pseudo first order reaction. Okay, there are so many examples. There are so many examples of pseudo first order reaction. Another reaction may be inversion of, another reaction may be this C12H22O11. This is sucrose, hydrolysis of sucrose in presence of acid. H3O, hydronium ion. Hydronium ion means acid. So what we get? We get glucose and fructose. Glucose and fructose. Molecular formula same. Glucose, fructose, molecular formula same, but structure different. ইহঁতৰ structure বেলেগ বেলেগ, কিন্তু molecular formula একেই. Glucose, fructose. Okay? This is hydrolysis of cane sugar. This is sugar. Sugar we eat. Sucrose. Chemically it is called sucrose. And reaction is known as hydrolysis of cane sugar. Again, this is first order reaction. Rate equal to K into concentration of this. Why? Because water is in large excess. Okay. Pseudo first order reaction. Now let us talk about second order reaction. Second order reaction. Okay. So once again, suppose this is a second order reaction. Let me write like this as before. This is R0. Okay, and this is 0 at time t. This is say RT, and this is PT. Okay, we consider that this is a second order reaction. So now if we write differential rate equation, it will be equal to dr by dt equal to dp by dt, and it is second order reaction, so we will write like this. Power is 2. Second order reaction. Okay. Now if we take just this dr by dt minus this is equal to k r square. Okay, and from this we can write like this: 1 by r square dr 1 by r square dr equal to k dt. Okay, then as before we will do the integration. আমি আগতেও ইণ্টিগ্ৰেশ্যন কৰিছোঁ, গতিকে ইয়াকো আমি এতিয়া ইণ্টিগ্ৰেশ্যন কৰিব লাগিব। উই হেভ টু ডু দি ইণ্টিগ্ৰেশ্যন। অ'কে, আৰু ইণ্টিগ্ৰেশ্যন কৰিলে কেনেকৈ কৰিম? ইণ্টিগ্ৰেশ্যন টাইম 0 to t. Similarly, integration when time is 0, concentration of r is r naught. When time is t, concentration of r is rt. Time is 0, concentration of r naught. Time is t, concentration of r rt. So we have to do this integration. Now you know, so say 1 by x square dx. Okay, let me write x equal to r. If we write x equal to r or r equal to x, so 1 by x square dx, it will be dx. So integration of this. So integration of this equal to x to the power minus 2 dx. Okay, now you know what is integration of x to the power n. Integration of x to the power n dx, that is equal to x to the power n plus 1 divided by n plus 1. Okay, here n equal to minus 2. So if we do this, minus 2 dx minus 2 plus 1 minus 2 plus 1, that means minus 1, x to the power minus 1 divided by minus 1. Okay, so it will be, if we do this integration, it will be x equal to this, that means r to the power minus 1 minus 2, then minus this, and limit is r naught rt. Okay, all right, x equal to this x. Okay, so this will be equal to k, kt. Okay, now x to the power, let me show you. So integration of x to the power minus 2 dx, that will be equal to minus x to the power minus 1, and that will be equal to minus 1 by x. Okay, so this will be equal to minus 1 by r rt r naught equal to kt, or minus 1 by rt minus 1 by rt minus 1 by r naught equal to kt. Okay, equal to kt, or 1 by r naught minus 1 by rt equal to kt. So we get this expression. Okay, Now once again we can find out half-life period. Okay, this is very simple. Okay, there should not be any problem, I think. So this is very simple. Now let us see half-life period. Let us see half-life period. Half-life period. Okay. Now once again, this is the reaction. So at T half, what we get? At T half, what we get? So this will be equal to R naught minus R naught by 2. R naught by 2. Okay. And so this will be R naught by 2. Okay. So half-life period. So K T half. K T half. K T half. Okay. K T half equal to 1 by R naught, 1 by R naught, and minus 1 by, what is RT? RT equal to R naught by 2. R naught by 2. Okay, RT equal to R naught by 2. Okay, and this is equal to 1 by R naught minus 2 by R naught. R naught. I think I missed this. R naught. 2 by R naught. I have perhaps I have committed mistakes regarding sign. Regarding sign, perhaps I have committed mistake. Let me check it once again. Let me check it once again. This is minus this. This. So, I have committed one mistake. There is minus sign. Okay, there is minus sign, minus sign, minus sign, minus sign, minus sign. So I have committed mistake. Minus sign. Okay. So I have committed mistake. So this is minus sign. So I can write it like this. 1 by RT, 1 by RT minus 1 by R naught equal to KT. So I have committed mistake. Okay, I have committed. This is the correct thing. This is minus. So minus R naught. Okay. So this is the correct thing. So this will be R naught by 2, and this is R naught. Okay, because this is RT. 1 by RT. Okay, this is 1 by RT. So RT equal to R naught by 2, 1 by R naught. So this is equal to 2, and this is 1, 2, 1. So this is equal to 1 by R naught. This is equal to 1 by R naught. Hence, T half become equal to 1 by K R naught. 1 by K R naught. And K is constant. So I can write constant into 1 by R naught. That means half-life period of second order reaction is inversely proportional to the initial concentration of the reactant. Half-life period of second order reaction is inversely proportional. T half is inversely proportional to the initial concentration of the reactant. Okay, So you see, half-life period of zero order reaction depends on initial concentration of reactant. Half-life period of second order reaction again depends on the initial concentration of the reactant. But half-life period of first order reaction does not depend on the initial concentration of the reactant. Okay. Well, now we are talking about second order reaction. Now we have considered one type of second order reaction where we have only one reactant. আমি সেকেন্ড অৰ্ডাৰ ৰিয়েকশ্যন ডিছকাছ কৰি আছোঁ আৰু ইয়াতে আমি কি কৰিছোঁ, ইয়াতে আমাৰ ৰিয়েক্টেণ্ট এটাই আছে। অ'কে, চ' দিছ ইজ ওৱান টাইপ অফ ছেকেণ্ড অৰ্ডাৰ ৰিয়েকশ্যন where we have only one reactant. But this second order reaction may be like this also. Second order reaction may be like this also. Say A plus B, two products. Second order reaction may be like also. We have two reactants. So second order reaction may be of two types. Number one, only one reactant. Number two, two reactants. So second order reaction. Now once again here what we do initially concentration of this is this and concentration of this is this. Initial concentration. Okay, let us assume that at time t, we assume that at time t x mole of A and x mole of B are converted to product. Okay, because for the reaction to take place, same amount of A and same amount of B must go. If 1 mole of A reacts with 1 mole of B, 2 mole of A reacts with 2 mole of B, only then we will get the product. Okay, so from the equation what we find, one molecule of A reacts with 1 molecule of B, only then we will get the product. Or 2 molecule of A react with 2 molecules of B, only then we will get the product. Similarly, X of A react with X of B. So at time t how much remains? A naught minus X, this much remains. X is gone. Similarly, how much remains? B naught minus X. This say I call this say A and this say I call it B. Okay, now if we write differential rate equation, I can write differential rate equation like this: minus dA by dt equal to K AB. I can write differential rate equation minus dA by dt, or what is A naught minus X minus d dt A equal to A naught minus X equal to K. What is A equal to A naught minus X and B equal to B naught minus X. Okay, or just or we can write like this. If we do this, this is initial concentration is constant. Okay, so I can write it like this: minus d dt a naught minus minus plus d dt x equal to this. A naught is constant. A naught is constant. So d dt of constant is 0. So what we get? Or we get dx by dt equal to k a naught minus x b naught minus x. We get this. Okay. So we are getting this, or I can write like this: dx by a naught minus x, b naught minus x equal to k dt So this is equation 1. Now we are to, as before, we are to do the integration. Okay, but in this form it is difficult. to do the integration. So what we do? We do some calculations. So how we do the calculations? So first let us assume that this 1 by a naught minus x b naught minus x, this 1 by this, let me write it as p by a naught minus x plus q by b naught minus x. We assume this. Now if we simplify this, a naught minus x b naught minus x, so it will be p into b naught minus x plus q into a naught minus x. It will be this. So this is equal to this. So this is equal. So 1 must be equal to this. So p into b minus x plus q into a minus x, that must be equal to 1. Okay. This is equal to this. So lower portion is same. So 1 must be equal to this. Now here if we put if x equal to a naught, then what we get from 2? What we get? If we put x equal to a naught, okay, so from 1 what we get? P into b naught minus a naught, q 0, so this is equal to 1. So p will be equal to 1 by b naught minus a naught. P P will be equal to this 1 by. Similarly, what we do, we put x equal to B naught. First, we have put x equal to A naught. X equal to A naught. Okay, so that we get the value of P. Next, what we do, we put x equal to B naught. If we put x equal to B naught, then this will be 0. So Q will be equal to, now you see, if we put x equal to B naught, then what we get? Q into A naught minus B naught, Q into A naught minus B naught equal to 1. This is 0. A naught minus B naught equal to 1. So Q will be equal to 1 by A naught minus B naught. So we are getting the values of, so we assume this, we assumed this is equal to this. Okay, now we find out the value of P and Q. So we can substitute the value of P and Q here. Okay, we can substitute the value of P and Q. Let me put this 2. Okay, and this is 3. So this is from 3. So we can put the value of P, we can put the value of Q. So what we get? So you see, so 1 by, so that is from 2. So from 2. So from 2. Okay, from 2, 1 by A naught minus x. A naught minus x into B naught minus x, and this will be equal to, so we will put the value of P, so this will be equal to 1 by B naught minus A naught. Value of P is this, okay, value of P is this. So into 1 by A naught minus x, 1 by A naught minus x, Similarly, what is the value of Q? 1 by A naught minus B naught, okay, into 1 by B naught minus x, 1 by B naught minus x, or we can write it like this, 1 by B naught minus A naught into A naught minus x, plus 1 by A naught minus B naught, minus x. So I can do like this. Okay, now you see, we have to do this integration. We were supposed to do this integration. Okay, So for this, what I am going to write, we have already found it, this. So from 1 from 1 what we get? So from 1, okay, so from 1 what we get? um, dx by a naught minus x b naught minus x, that is equal to dx by b naught minus a naught, b naught minus a naught minus x plus dx a naught minus b naught and b naught minus x, okay. So and this is equal to this is equal to k dt, okay. Now integration, so we will integrate from 0 to t, okay. If we integrate from 0 to t, so when t is 0, x is 0. When t is 0, x is 0, okay. Nothing is converted from a to b, a and b to product. When t is 0, nothing is converted from a and b to product. That means x equal to 0, okay. And when at time t, this will be equal to xt, this will be equal to xt, okay. So what we write? At time t we write this is xt, okay, xt. So or let us do this integration. So this portion is constant, so I can take it out. 1 by b naught minus a naught, I can take this portion out and I can write it like this: 0 to xt dx in a naught minus x, similarly plus 1 by a naught minus b naught and integration 0 to xt, this is 0 to xt 1 by dx by b naught minus x, okay, and that is equal to kt, okay. So now if we do this integration, what we will get? Or this is just like integration 1 by x, this is constant, so it is just like integration 1 by x dx, but there is minus sign. So what result we get? This will be minus 1 by b naught minus a naught ln a naught minus x 0 xt, okay. Then plus again this is minus 1 by a naught minus b naught a naught minus b naught ln b naught minus x 0 xt, and this is equal to kt, or or I can write it like this. If I write it a naught minus b naught, I can write a naught minus b naught, then it will be minus. So it will be 1 by a naught minus b naught. Okay, a naught, then minus will be plus. So this will be ln a naught minus xt minus ln a naught plus means minus, 1 by a naught minus b naught, ln b naught minus xt minus ln b naught equal to kt, or just simplification, I can do it like this. I can take this common, 1 by a naught minus b naught, I can take this common, so then it will be ln a naught minus xt minus ln a naught minus ln b naught minus xt is plus ln b naught equal to kt. So we get this. Or we can arrange it like this, log m minus log n, we can arrange like this, or 1 by a naught minus b naught. Okay, then ln log m minus log n, so ln a naught minus xt by b naught minus xt, then log m minus log n, so plus ln b naught by a naught equal to kt. Okay, again log m plus log n, so I can write, or 1 by a naught minus b naught ln, so ln b naught into a naught minus xt and b naught minus xt a naught, okay, equal to kt. So this is the result we get by integrating the differential rate equation for second order reaction of the type A plus B to products. Okay, so in this way we can do some calculations. We have to do some problems also, but for the time being let us stop here, and in the next class we'll solve some problems and do some other things. Okay, thank you.